Hope everyone can hear me. All right. Please, I want every other person to talk so that I will know that everybody is following. Can every other person hear me?
Yes.
All right. All right. So without wasting much of our time, let's get started. So I will share my screen right away. So can we all see my screen?
Yes, we can see.
All right. So the topic cover of this class is the roadmap to becoming an embedded system developer. So I organized this program because I've been receiving a lot of messages from different persons, people asking you how they can be able to start programming microcontrollers, a lot of questions altogether. So I decided to put up this program so that we can be able to answer all these questions once and for all. Then before, when I started my journey some years back, I encountered a lot of challenges. I watched a lot of YouTube videos. I asked questions, but I was not able to get a very cogent point. But along the line, I met someone that helped me, that guided me. So that was the exact reason why I decided to organize this program so that I can be able to extend that good way to other persons, because I know that a lot of persons are finding it very difficult to start. The most important thing is to start. Once you've started, the journey becomes very, very smooth. Hope we all can hear me. Hope we all can hear me.
Yeah.
All right. So we are going to be. I outlined the necessary step one needs to follow if you want to become an embedded system developer. But before that, I want us to understand the meaning of embedded system developer. Now, when you talk about embedded system, you are talking about computer inside a device. For instance, you have your vehicle and you have airbag inside your vehicle. You have your traffic lights, all those things that are embedded system devices. So you have a lot of them everywhere. Now, before you become an embedded system developer, you don't just jump into programming microcontrollers or working on development boards. There are things that you need to do before you start programming microcontrollers or doing embedded system in proper. Now, the first thing that you need to do, the most important thing is that you need to go through the fundamentals of electronic design. That is the first thing. What is fundamentals of electronic design? You should be able to know how to use diode. You should be able to know how to use resistor. You should be able to know how to use transistor. You should be able to know how to use a relay. Because if you cannot use these basic devices, these basic electronic components, it will be difficult for you to build a full system with it. Now, when you start programming your microcontroller, you are going to have issues. Let's say you are building a system and you are having a problem. It will be difficult for you to differentiate whether the problem is coming from the hardware, which is the electronics, or whether the problem is coming from the code, which is the firmware. So the first thing you do is understanding the basics and the fundamentals of electronic design. You should be able to know when a particular resistor is not good. You should be able to know the value of resistor to put at the base of a transistor. So these are the fundamental things that you need to know. You need to familiarize yourself with electronics components, be it resistor, capacitor, diode, transistor, LED, LDR, and what have you. Are you guys following?
Yes.
All right.
Yes, we are following.
All right. So now I've talked about the first one, which is knowing the fundamentals of digital or fundamentals of electronics. Now the second thing is when you go through these basic fundamentals, you do what? You start building projects. You start building projects. You cannot learn without building projects. You see some persons, they will pick up a particular programming language, they will start after printing hello world, doing a lot of things, knowing how to declare variable and what have you, they will stop there. You can never be good without you doing projects. So after knowing the fundamentals, the next thing to do is trying to build projects. Lay your hands on projects and start building. So this was the first project I did. This welcome to SEC. That was the first project I did back then, more than 5 years ago. That was the first project I did when I started embedded system or electronics, what have you. That was the first project I did. So you can pick up LED lights. You have a lot of projects. Temperature control, maybe motion control devices. You can do automatic changeover. We have a lot of projects that you can work on as a beginner. So number one thing is for you to understand the fundamentals of electronics. Second point is for you to lay your hands on projects. Start building projects. Because you can never learn. It's not possible for you to learn without building projects. So that's the second thing you need to know after understanding the fundamentals. Try and cover one or two things. Then the next point. Okay. The program is. What do you say? I can't hear you. Please, can you ask your question again? Okay. Sorry about that. I will try as much as possible to be slow. All right. So the next thing you do after trying your hands on a lot of projects, the next thing you do is number system and logic gates. Now, after building projects like building basic electronic circuits, maybe using 5 timer, using op amp, LM234, LM386, and what have you. After building these basic projects, the next thing you do is you start learning about number system, especially binary and hexadecimal base 2 and base 16. So that's the next thing you do, and also logic gates, because if you want to program FPGA, I'll still get there. I just want to explain one or two things with FPGA. If you want to program FPGA, you must be familiar with logic gates, latch, and what have you. So you must be familiar with logic gates, combinational logic circuit, and what have you. So the next thing is for you to understand number system and logic gates. So once you are okay with number system and logic gate, if you don't know what is logic gate, I built this device. This is a logic gate training kit. So we have basic logic gates, we have OR gates, we have NAND gates, we have AND gates, we have NOT gates, we have XOR, we have NOR, and we have XNOR. So these are the 7 basic logic gates that we have. So you understand the two tables of logic gates, understand how they work, when you put 0, 0, what will be the output. So after doing that, the next thing you do is you start with C programming language, because most of the controllers that we know, you program them using C programming language. You can actually use other languages like Python, like assembly language, but conventionally a lot of persons use C programming language. I actually started with assembly language, but with time I transitioned to C. Okay, so after that, after you must have been comfortable with C, like the basics of C, you learn how to declare variable, do basic mathematics, addition, subtraction, and what have you, conditional loop, and what have you. So once you are comfortable with C, the next thing you do is you delve into microcontroller proper, because as an embedded system programmer, what you are doing is that you are programming microcontrollers. So at that point, you are no longer concerned with the circuit design. Fine, you are going to design your circuit, but that is not going to be your fundamental problem. What you are doing now is the ability to write firmware, which is C programming language. So this is microcontroller and development board. So I will explain the difference between microcontroller and development board, because some persons most times they mistake these two devices. So microcontroller is a chip, is a computer, mini computer, a special purpose computer. That is microcontroller. It's called a special purpose computer because it's dedicated for a specific task. Let's say you want a device that is going to monitor the temperature of a room. You are using your controller to do the work. So you are specifically monitoring the temperature of a room. It's not like your personal computer, which is multi-purpose. You can be playing music with your laptop. You can be designing using a CAD software. You can also be doing another thing using calculator. But your special purpose computer, which is microcontroller, cannot do all those tasks at a go. Though you can use interrupts, but what's actually happening is that if you want to interrupt, one particular task will stop and execute the other one before it will now go back to the previous task. Now, what is the difference between development board and microcontroller? So these are Arduino development board. Hope you guys can hear me. Are we together?
Yeah.
All right. So what's the difference between microcontroller?
Hello.
Yeah, I can hear you.
So what is between Java and Python or C++?
Can you ask your
Programming, embedded programming, which is better?
yes? C++ is actually better. You know why I feel C is better? Now, when choosing a programming language, the first thing you think about is the community. Let's say you are working on a project and you are having problems. It will be very easy for you to find solution when you are using C programming language for microcontrollers than Python. So C has a larger C++ has a larger community when compared to Python. So let's go forward. Now, what's the difference between microcontroller and development board? In this case, we have Arduino Uno. So now, microcontroller is just a chip, and development board is a board that has microcontroller inside with other components. So inside here we have controller. This is the microcontroller inside. We have capacitors, we have crystal oscillator, we have pin headers, we have USB connectors, and we have a lot of components here. So what you have to do just for you to plug this development board to your laptop and you start programming it. But if you want to use the controller, you need to do what we call minimum configuration. So before a controller can start working, you must do what is called minimum configuration. You must add oscillator, which is crystal. You must add capacitor. You must add reset resistor. But all these things, they have already integrated all these things inside one board. So you don't have to worry about all these things. What you also have to worry is just to plug your development board to your computer and you start using it. So Arduino is not a microcontroller, rather it's a development board that has a microcontroller inside. So now, after you must have passed through this step, which is understanding microcontroller. So once you understand microcontroller, you go through the architecture, because what you are actually doing is programming the pins of the microcontrollers. Like ATmega 328P, which is the microcontroller inside Arduino board, is a 28-pin microcontroller. So what you are doing is actually using your code, which is C, C++, to control the pins of your microcontroller. That's what you are doing. So you need to understand the pins, know the one that is pin 1, pin 2, know the analog to digital converter pins, know the digital pins, the power pins, and what have you. So you need to understand the microcontroller architecture, know the memory size, know the EEPROM size. Maybe you want to write a code that will take in some values and store locally inside the microcontroller. You need to understand these basic things about microcontroller. Then, after that, the next thing you do is you start working on sensors, interfacing sensors and modules to your microcontroller. So we have a lot of sensors that you can work with. You have a lot of sensors. This is motion sensor, this is ultrasonic sensor, this is temperature sensor, DHT11, and this is a power module. So with this module, you can read the voltage, the current, the frequency, the power, and the energy of a particular energy source. So you can use it. I actually did a project that I use this module, an IoT-based meter, smart meter. So this module is very, very powerful. So after you must have understood the basics and the concept of microcontroller, and also you've gone through the architecture, the next thing you need to do is start using C programming language to program your microcontroller. Then I forgot to make mention of something. We have different types of microcontrollers. So you can make your choice. We have 8051 microcontrollers, we have AVR microcontrollers, we have PIC microcontrollers, we have STM32 microcontrollers. So we have a lot of them. So now, after going through this, the next thing you do is that you start building projects. So after this module, you start building projects, because as I said before, it's very, very difficult to learn without working on different projects. I understand that the reason why a lot of persons run from embedded system or electronics programming is that you need to spend money. It's not like normal. I do mobile app development too. So it's not like mobile app development or web development where you source all your materials online. Once you have data, you can download what have you. If you are doing what is it called now? If you are doing mobile development, you can download your Android SDK, Flutter SDK, or what have you. You can download everything online. But this one is entirely different. You need to spend money buying components. This is very, very important. So the more you work on projects, the more your experience level increases. So the more you work on projects, the more your experience level increases. So then, after that, you can decide to jump into PCB design. I actually designed this using a PCB software called KiCad. So we have a lot of PCB design software. We have Eagle, we have KiCad, a lot of them, there are plenty. So you can decide to choose any one Because naturally, when you are learning, you use Vero board, you use breadboard to connect your components together. But after that, you might want to start printing your own PCB. You don't want to put that on breadboard again, sorry, on Vero board, or you want to print your PCB. It's actually very cheap to print PCB. You can use their PCB. It's just $2 to print 5 PCB. So you can start designing PCB. But if you are not interested, then you start working and developing yourself, because the more you work on projects, the more experience you gather. The more you work on projects, the more experience you gather. So at this point, I will start entertaining questions. So if you have any question at all, you can do well to turn on your mic and ask questions. Can you all hear me?
Yes, I can hear you.
All right. So
I can hear you very well.
all right. So if you have any question, you can ask your question now. So I want to assume that all of us we understood what I just said now. Is that what?
Hello.
Yeah, I can hear you. Sorry, can you ask your question again? I didn't get it. Maybe you can use the chat box, because I can't really hear you.
Hello.
Yeah, I can hear your voice, but I can hear your voice, but I can't.
Interface is okay. Text in the box, chat box.
Sorry, I can't hear you. Sorry. Can you type it on the chat box? Can you use the chat section to type your message, because I can't hear you? Okay, do any other person want to ask question? Or are we good? Then we call it a day. So the first point I raised here is that we should be familiar with the fundamentals of electronics design. So in this particular part, you should familiarize yourself with the basic electronics components like resistors, capacitors, diodes. If you know how to identify the value of a resistor, if you know how to use your multimeter to check whether a particular component is good or bad. So this is the first part. So the second part is you start working on projects. You start laying your hands and doing some projects. Like this is the first. All right, let me check. Okay, for interfacing microcontroller, is there necessary to calculate the address line and data line? Okay, now it depends. Let's say it depends on the language you are using. Let's say you are using assembly language. When you are using assembly language, you do more of register programming. So you manipulate registers. But if you are using C++, what you have to do is just for you to declare variable. Most times, you don't necessarily need to access any address, unless if, let's say for instance, you want to use EEPROM. So you need to know the location that you are writing your data to. You want to use EEPROM to save your data. So you need to know the location, the exact location that you are writing your data to. So in that case, you need to access a particular memory location. But when you are doing your general programming, maybe interfacing temperature sensor, you don't care about addressing. So what you care about is, let's say you want to interface 5-6 temperature sensors, and you are using a particular protocol, let's say I2 protocol. So then you need to scan the address of each of the components so that you can be able to address them properly. But generally, you don't have to care too much. You don't have to worry too much about addressing when you are doing your when you are doing your sensor or module interfacing to the microcontroller. I don't know if you are okay with that answer.
I think there's another question there.
All right.
Yeah.
Okay. Okay. Yeah, we have what I use Pro Tools. Hope you can see my screen now. Can you guys see my screen?
Yes.
All right. So I use Pro Tools simulation software to simulate my circuit. So let me look for a circuit that I've already simulated. So you can simulate Arduino using the simulation software. You can use Pro Tools. That's what I use most times. Pro Tools simulation software. So the code is not here. I guess so. No code here. I can't find the code now, but you can use Pro Tools simulation software. Pro Tools. So I want to send that to the chat box. So that's the name of the software, Pro Tools simulation software. So any other question? All right. So after you must have done project. All right. You can ask your question.
Okay. How many developers does have the process simulation library? How many available?
Okay.
I only found Arduino only. If I want to use USB Arduino or any other Raspberry Pi
Yeah.
I don't get the models for process.
Yes. You can get Raspberry Pi library for Pro Tools, like Raspberry Pi and Arduino, but I've not seen that of ESP32 boards or Node MC. Yeah, I've not seen Node MCU and ESP32 boards, but you can get Arduino Uno, Arduino Nano, Arduino Mega, and what have you. Then also Raspberry Pi too. So I have an okay. Are you okay?
Yeah, I'm okay.
All right.
But why don't we use some other software that can include all other blocks?
Okay. Now it depends on the availability of the software. What most persons use or what I use Pro Tools for simulation, for simulating basic controllers. So I'm not used to any other simulation software, but if you know any other one, maybe you can tell us. But basically, people use Pro Tools for simulation of microcontroller. So I have a question here. Someone asked a question. Do you train people on this? Okay. Maybe I'll answer that on the group chat. If yes, how can I get trained, like cost and period? Okay, I'll answer this on the group chat, on the WhatsApp group chat. So the next question is, can you recommend external resources for learning? Okay, let me answer this particular question. Now, if you are starting up embedded system development, I usually advise people to get someone that will guide you. Just get someone that will guide you. If you can get somebody that can guide you for just 3-4 weeks, from 3 to 4 weeks, you are okay. It becomes very, very easy for you. You can watch YouTube videos, you can use Google. But at that starting point, it's usually good to stay under somebody. I actually stayed with somebody for about 2 months. I stayed for about 2 months. Then after the 2 months, I started working on my own, because it's very, very easy for you to keep going when you've gotten the fundamental. You can explore. I started with 8051 microcontroller. But after 8051, I started using a lot of controllers, STM32, AVR microcontrollers, like that Mega 32, Mega 328, Mega 16, and what have you. So for a beginner, I always advise people to look for someone that will guide them. Then with a period of one month plus, yeah, okay, you can start learning on your own, watching YouTube videos and using Google as well. So the next question, I have another question here. Can C++ and Arduino be used for the same project? If you want to program controller, either if you want to use Arduino IDE, the name is, we call it Sketch. If you want to use Arduino Sketch, use Arduino Sketch and program your microcontroller. But if you don't want to use Arduino Sketch, you can use other IDEs. We have a lot of them. Like for AVR microcontroller, you can use Atmel Studio. For AVR microcontroller, you use Atmel Studio. For 8051 and STM32, you can use Scale Microvision. So we have a lot of IDEs. But if you want to work with Arduino boards, you can use Arduino IDE. That is Sketch. So you cannot use two separate IDEs together. I don't know if you are getting my point. Have I answered your question, Timothy? Okay, please, can you type the name of the IDEs? Okay, so we have Scale, we have Atmel Studio, sorry. So we have Atmel, we have Scale, we have Atmel Studio. Atmel Studio. So Scale Microvision, thank you, Kiran. Scale Microvision is for 8051, for STM32. Then Atmel Studio, you can use it for AVR microcontrollers, any type of AVR microcontroller. So I have a lot of them. You can Google, you can use your Google. So it's all right. Any other question before we call it a day? All right. So at this point, I want to say thank you for attending the webinar. So goodbye, everyone. If you have any other question, you can drop it on the group chat. Thank you very much. All right. Thank you.
Yeah, thanks so much for the presentation.